Have you ever wondered if our universe is the only one? It sounds like something straight out of a comic book, right? But what if I told you that the idea of a multiverse isn't just science fiction? It's a concept that has grown out of some of the most advanced theories in modern physics, from cosmology all the way to quantum mechanics. The core idea is that our universe, this vast expanse of stars and galaxies, might just be one bubble in a cosmic ocean filled with countless others. Each of these other universes could have its own unique set of physical laws, its own constants, maybe even its own version of reality. This mind-bending possibility has captivated scientists, because it might just hold the key to solving some of the deepest, most persistent puzzles in physics. So, stick around as we journey through the science, the controversy, and the profound philosophical questions behind the multiverse. One of the most compelling reasons scientists even consider the multiverse is something called the fine-tuning problem. It's one of the biggest mysteries in cosmology. When we look at the fundamental constants of our universe, things like the strength of gravity, the mass of an electron, or the energy density of space itself, we find something astonishing. These values seem to be perfectly, and I mean perfectly, balanced to allow for the existence of stars, planets, and ultimately, life. If you were to change any of these numbers by even a tiny fraction, the universe as we know it would be impossible. Stars wouldn't form, atoms would fly apart, and there would be no chance for complex structures like us to ever emerge. So, why is our universe so exquisitely fine-tuned for life? Is it just a massive, unbelievable coincidence? A lucky accident? Some physicists find that explanation unsatisfying. This is where the multiverse comes in. The multiverse hypothesis offers a different perspective. It suggests that there isn't just one universe, but an enormous, perhaps infinite, number of them. In this vast collection of universes, the physical constants are different in each one. Most of these universes would be sterile, chaotic, and completely inhospitable. They might collapse in on themselves moments after they begin, or expand so rapidly that no structures could ever form. But, in this cosmic lottery, it's statistically inevitable that a few universes, or maybe just one, would happen to have the exact asterisk right combination of laws and constants for life to arise. And, of course, the only universe we could possibly observe is one that allows for observers to exist in the first place. This is known as the anthropic principle. It's not that our universe was designed for us. It's that we could only exist in a universe that looks like this one. So, the fine-tuning isn't a miracle. It's a selection effect. We here talking about it because we in one of the rare universes where that's even possible. It's a neat and elegant solution to a very tricky problem. But hold on, because not everyone in the scientific community is on board with this idea. In fact, the multiverse is one of the most hotly debated topics in modern physics. The biggest criticism, a core principle of the scientific method is that a theory must be testable. You have to be able to design an experiment that could, at least in principle, prove it wrong. But how can you test for the existence of other universes if, by their very definition, they are separate from our own and we can't interact with them? If there's no way to observe, measure, or communicate with these other realities? Critics argue that the multiverse steps out of the realm of science and into the world of metaphysics or philosophy. Then there's the principle of Occam's razor. This is a philosophical rule of thumb that says the simplest explanation is usually the best one. When faced with competing theories that have the same predictive power, we should choose the one with the fewest assumptions. For opponents of the multiverse, postulating an infinite number of unobservable universes is the opposite of simple. It's a massive, unnecessary complication. Why multiply realities, they ask, when we're still struggling to fully understand the one we're in? This brings up a fascinating philosophical question. Can an idea be logically sound and potentially true, but still be considered bad science, because it offers no testable predictions? The debate rages on, and it really cuts to the heart of what we consider to be scientific knowledge. Let's dive a little deeper into one of the theories that gives rise to the multiverse. String theory. String theory is one of the most ambitious and mathematically complex ideas ever conceived in physics. It's an attempt to create a theory of everything, a single framework that can unite quantum mechanics, the physics of the very small, with general relativity, Einstein's theory of gravity. In string theory, the fundamental building blocks of reality aren't point-like particles like electrons and quarks. Instead, they are unimaginably tiny, one-dimensional vibrating strings. Just like the strings on a violin can vibrate at different frequencies to produce different musical notes, these fundamental strings can vibrate in different ways to create all the different particles we see in the universe. So, where does the multiverse come into this? Well, the equations of string theory don't just describe one possible universe. Instead, they point to a vast, almost infinite collection of possible universes, known as the string landscape. This landscape is estimated to contain something like 10 to the power of 500 different possible vacuum states, each corresponding to a universe with its own unique set of physical laws and constants. Our universe, with its specific values for gravity, the speed of light, and particle masses, would just be one of these countless possibilities. The string landscape provides a theoretical foundation for the multiverse idea we discussed earlier. It suggests that the fine-tuning of our universe isn't a fluke, but just one outcome among a staggering number of possibilities predicted by a more fundamental theory. However, even with these incredibly bold and fascinating ideas, we are left with some profound limitations. Neither string theory, for all its mathematical elegance, nor the standard model of particle physics, our current best description of fundamental particles, can fully explain why our universe has the exact properties it does. Why do fundamental particles have their specific masses? Why is the force of gravity so much weaker than the other fundamental forces? Why is the universe expanding at the rate it is? These are known as the free parameters of the model. They are numbers we have to measure and plug into the equations by hand. The theories themselves don't explain where they come from. The multiverse offers one potential, albeit controversial, way out. It suggests there is no deep reason for these specific values. In the grand cosmic landscape, all values are possible, and we just happen to live in a universe with this particular set. But if we reject the multiverse, we're back to square one. We're left with the deep and unsettling mystery of why our single, solitary universe seems so perfectly tailored. Is there some deeper, undiscovered physical principle that dictates these constants must be what they are? Or are we missing a huge piece of the puzzle? Ultimately, the question of the multiverse pushes us beyond the boundaries of science and into the realm of existential reflection. If the multiverse is real, it redefines our place in the cosmos in the most dramatic way imaginable. Our entire observable universe, everything we've ever known or will ever know, would be just one tiny, insignificant patch in an unimaginably vast and diverse reality. Our existence, our history, our future would be just one story among an infinity of others. But if the multiverse isn't real, if our universe truly is all there is, then we are left with an equally profound mystery. Why this universe? Why is it so perfectly suited for complexity and consciousness? Does that imply something special about our existence? Either way, we are confronted with a question that touches on the very nature of reality itself. Whether a scientific breakthrough one day provides an answer, or it remains a subject for philosophical debate. Exploring the idea of the multiverse forces us to confront the deepest questions we can ask. Thank you so much for joining me on this journey through the cosmos. If you enjoyed this exploration of mind-bending physics, don't forget to hit that like button, subscribe to the channel, and ring the bell so you don't miss our next adventure into the unknown. See you next time.